have 16, 17 Pascal. No, 18, no? I think 18 with me. This one. So, so can you hear me?
Yes, sir.
Yeah. Okay. Okay. So today we are going to start another module. It's called mechanical behavior of materials. So yeah, today actually we are going to do some introduction session like yesterday one. What are the things we have to cover and how we are going to cover those things and what are the ways you can earn your marks for your grade. Okay, so these are the intended learning outcomes. So first one is recognize the generic behavior of stress and strain, stress, strain and mechanical response in metals, ceramics and polymer, as well as the various similarities and differences. The second one, interpret the atomic scale origin for specific aspects of stress strain materials. Example, Poisson ratio. Third one, explain the property called hardness of materials and their characterization techniques. Fourth one, contrast material response under specific condition to actual experimental settings. Fifth one, compare the differences and similarities of tensile and compressive stresses in materials. Realization the results of stress strain diagram and also the bending behavior of the materials using fractural test results. Sixth one, evaluate the maximum allowable load in which a material is incapable to stand without fracture. Finally, criticize the fracture fatigue and creep behavior in basic types of materials. So this is your learning outcomes. It's quite big, and yeah, this subject is somewhat deeper one, and especially which are very much associated with mathematical equations and calculations. So I hope you all get in touch with the subject every time. Otherwise, maybe sometimes it will be much harder to come to the track. Okay, so I suggest you to at the beginning. I mean, from the beginning. So it's better to realize every each of theories and the things what I learn, what I teach, and so then it will be more easy for you. So those are our learning outcomes, and at the end of the day, you should be able to describe and figure out those things. Okay. So sometimes you may hear some background noises. Sorry for that. Okay, so this is our content, introduction, and so normal stress and strain, tensile test, properties obtained from tensile test, bending test for brittle materials, then inelasticity, Hooke's law and Poisson ratio, shear stress and strain, allowable stress and allowable loads, design for axial loads and direct shear, analysis of stress and strain, including Mohs circle, hardness of materials, impact test, Why? Then the fracture mechanism. So there are a few subtopics under fracture mechanisms and fatigue, similar like fracture mechanisms. Then creep, stress rupture and stress corrosion. Then creep, finally evaluation of creep behavior. So those are also it's pretty much similar. One like 14, 15, and 16. So normally we have 14, like 14 sub topics we have to cover. Okay. Uh, in addition to that, you have so you are supposed to do these practical sessions to complete your to complete this module. Especially in the practical sessions, we are very strict on the practical sessions. So it should be, 100% attendance should be there, okay, to fulfill the practical sessions. So in the practical sessions, we are covering the determination of tensile test of different materials, and also the compressive test, bending strength, then hardness test also, Vickers hardness, Fresnel hardness, and Rockwell hardness. So those are the things we are going to cover. So altogether we have 6 practicals. Okay. Uh, so actually, I'll make the practical schedule as soon as possible and I'll share with you. Then we can start the practical schedule simultaneously. Okay. With the then okay. So this is your grading criteria. So the continuous assessments like class assessment, quizzes, and homeworks, it takes 30%, and practical sessions take 20%, and finally the end semester examination, it takes 50%. Okay, the marks. So altogether you can get 100% uh, from the from these places. Okay. Okay, then this is the book that I refer for you, suggest for you to refer the Russell C. Hibler Mechanics of Materials 9th edition. So there are a few editions actually. First, second, third, likewise 9. So normally these editions have some differences. So it's better to you can refer the 9th edition. So if you want the soft copy, please request me. So I have the soft copy, so I can share with you. Uh, so this is a very good book for a subject. Actually, I highly recommended this book. So this contain everything that I'm going to teach. Okay. Okay. Now we come to our part, introduction to mechanical behavior of materials. Okay. So what is the mechanical behavior of material? First of all, we should know about why we are going to learn such thing. What is the importance of the mechanical behavior or mechanics of materials? Okay. Okay. First think about it. What is the mechanical behavior means? What is the mechanics means? So definitely, as a material student, you should be, also you're supposed to learn the materials. So you can't escape from this. But what is the mechanical? Why we add in some term that called mechanical with the materials? Okay, what is the mechanical means? So normally mechanical means when something associate with a force, so we called it. I mean, some of the things can be held due to the force. So then that kind of places. So we are going to study the mechanical behaviors. So what are the forces and how they are, how the that in such places. Okay, so then behavior of that interpretation, we normally we call some name, or we have some names to put. Sometimes we call there are stresses. Sometimes it, for the compressions. Sometimes strains. Strains actually kind of happen of these stresses and compressions. Then sometimes we call pressure, force. There are so many I mean related words in the mechanical behavior of material stream. So normally mechanics of material. So mechanical behavior both are same. In the branch of mechanics that study the internal effect of stresses and strains in a solid body that is subjected to an external load. Okay. So what is the we are going to find, or we are going to explain what happened when sometimes subject a force, what happened to the material or what happened to that object. Okay, how the internally uh, it creates some effects, how we describe those things. So this is the main thing we are going to describe, or we are going to understand from the subject. So stresses. So here I just show something. So stresses, no, it affects strain, and strains it affects deformations. So likewise that. So the figure also say, okay, there's a bridge and a car on the bridge. Then what happened because of that car? The bridge subjected on some particular load. So because of that load, okay, it create a force. Then what happened? Then what is the main focus of this subject is, so we are going to look what happened to the bridge, what happened, what are the internally created loads or forces due to this external load or external force. Okay, so that is, I mean, especially in engineering, it's very important case, because once we are going to design something, we have to think these things. Okay, so you also, I mean, may notice sometimes there are various type of bridges. Some bridges are like it's very straightforward and no any supports, but some are not like that. There are some supporters at the bottom, and sometimes some are supports like at the top. Some supporters are at the top. Okay, there are so many designs. Okay, so all that kind of designs has a reason. Okay, so that reason comes through the design procedure, and that design procedure beginning with this mechanical of materials, or we can say mechanical behavior of materials, or mechanics of materials. So that is the origin part. That is the origin. Okay, so we are going to learn this origin. Okay, so this is some sort of a serious subject. That's why I talk. Okay, first of all, we just go through what is the history of this subject. Okay, every subject has a history. So then we just briefly go through this history. So we may find some of scientists who mm, uh, yeah, who invented something, some of theories, some of what we call equations, like that. So first of all, we can go back to that Leonardo da Vinci. Okay, I think you all know this person. He's a great scientist. And from that era, he was the best. Like mm, like Newton or like Einstein. Okay, that era, Leonardo da Vinci is one of the greatest scientists. Okay, then uh, in in our subject, okay, he invented this one sketch possible test to find a tensile strength of a wire. Okay, so he sketched possible test. So what is the test that we can use to find a tensile strength of a wire? Okay, you may learn future in later. So what is the main importance of the tensile strength? Okay, what is the difference between tensile stress and the strain? Okay, then Galileo, he had invented the breaking loads of rods concept of stress. Then Robert Hooke, materials displacement under load were proportional to the establish the elasticity. Okay, so uh, we have a equation called Hooke's law. Okay, so it's a very fundamental equations that we should use to find the elasticity. So Robert Hooke is the person find that law. Then Leonard Euler, the linear relationship between stress and strain. Sometimes you may find that name of the Euler name in your math subjects. Okay, so Euler is a very famous scientist, very famous mathematician. Then Thomas Young developed the idea of Young's modulus. This is also one of the fundamental equation that we use. Then Charles Augustine Coulomb developed expression of the stress due to the pure bending. Bending also important one, very important, very fruitful equation for the bending equations. Then Antonio Pay introduced the concepts of shear stress. So this is kind of a brief history, and especially the persons who is contribute their knowledge to betterment of the subject. Then yeah, then once we come to our part, it's about first we have to know what is the equilibrium. Okay, what is the equilibrium, and how the equilibrium can find and how we can define the equilibrium. Okay, so can anybody say what is the equilibrium? What is the meaning of the equilibrium? So, so what do you feel when somebody says in equilibrium? Okay, what happens something in equilibrium? Let's see. I'm saying a ball is in equilibrium. then what happened to the ball? Or what happened to the in anything? Can anybody say? Anybody any suggestion? It doesn't matter. Uh, I don't want the correct answer. What do you feel? Then somebody say it's about equilibrium. What is the main two states when something in equilibrium? Nobody knows? Any idea? Doesn't matter. So don't hesitate. Somebody, yeah, yeah, it's kind of a balance. It's partially correct. When we say something in equilibrium means all the forces that are subjected by the environment or by subjected externally should be balanced. Okay, then if something is in equilibrium, that means this object or that object is in a what we call static. That means it doesn't move, or else it can move with a constant velocity. Okay, that means it doesn't have any no, I mean it has some dynamic characteristics, but it's not actual dynamic. Okay, something has only two states. First thing, it's in a stable position, or else it's in a stable. Definitely it's in a stable position. On the other hand, it's it doesn't move, or it has a constant velocity. Okay? Both things can happen. Okay, you know that Newton's second law, it says that something is in equilibrium, either it doesn't move or it has a uh, constant velocity. Simply we can say like that. The Newton's second law. So that second law is called about the or states about the equilibrium. Okay. So we actually refer that Newton's second law once we talk about the. Okay, there are so two type of external loads here: surface loads and body forces. Okay, so body forces also we can say it as external load because why we can say the body force is external load? Actually, it comes from internally, but actually it has external load because the body force always creates with related with the gravity. Sometimes body force is not sometimes actually always body force is lower in the moon. No, yeah, on the moon our body force is lower because the gravitational force in the moon is low. So then we are on the moon surface. So our body force is low. But here it's not like that. So once we go another type of planet like Mars, Jupiter, Saturn or something, so then that body force will be varies. Depend on the gravity and depend on sometimes it may happen from magnetism. That's it. Doesn't actually much doesn't have that much impact, but yeah, sometimes we have, especially sometimes for objects. Okay, normally humans does not affect that much, but yeah, it has some effect, but not it's a kind of a very weak force. But especially once we have some object with some ferrous or iron, then yeah, it has some considerable uh, force. Okay, so then surface forces also we can categorize as a few types. First thing, concentrated force. Okay, so we can interpret in a one line concentrated or linear distributed load. Sometimes the loads can be have with a linear distribution, and also we have sometimes non-linear distribution. uh, so normally we are not going to discuss that non-linear thing. It's a very difficult thing to deal, so we are not going to that much deeper, but of course linear things and concentrated forces we should be talk. Okay, so and also here we are going to always talking about the 1D cases. Okay, not 2D or 3D case. So once we go to the 2D and 3D, so it may be quite difficult, but I think 1D is we limited with the 1D, as I guess. Anyway, I'm not sure. Sometimes we may have the 2D case as well, but obviously not 3D. Okay, then we have some support reactions. Wait. Okay. Okay, then yeah, once we are going to uh, solve some equilibrium problems, okay, we may come across with these type of different kind of what we call that orientations, okay, and also some sort of different bindings uh, like that. So in the different orientations and different that bindings has a different type of reactions. Okay, let's see. If we have a cable, then you can see what is the force, what is the reaction, sorry, what is the reaction force. Okay, if he has a roller, so what type of reaction force we have. Okay, we supposed to use, and it's a smooth support. So then this is the external pin. Okay, so this is very common one. Okay, we have. So then we have to use two reactions. I mean, two reactions means this is kind of a simplified method. Normally it has a resultant one, but so normally we use two I mean, two legs of the forces. Hmm, two parts. We divide two parts. So along with the x-axis and along with the y-axis, then it will be more easier to find the solution. Then internal pin. What happened when we have an internal pin? So what kind of reaction forces we have to use use, and also once we have a fixed support. Okay, so this kind of fixed support, that means it fixed to the wall. Then how we are going to find. Okay, so this is kind of we call this type of beams cantilever beams. Okay, normally in the structural engineer cases, we should study more of these type of beams. Okay, but in our case we don't have that. But anyway, knowing of these things are better. Okay, now we come to the equation of equilibrium. The equilibrium of a body both require, yeah, equilibrium of the body both requires both equations, actually both balance of force and balance of moment. Okay. Uh, so to prevent body from the translating or having accelerated motion along straight or curved path, to prevent body from rotation. Okay, so normally what we should know. So if our object is in equilibrium, then it should be balanced with first with the force, then balance with the moments also. Why we want to balance forces? To prevent the body from translated or having accelerated motion. Okay, because once it has a resultant force to either side, then it may cause for the acceleration. Okay, I think you may know what is the acceleration means. So we have a velocity and the acceleration. So acceleration means we have some increment of the velocity. Okay, the velocity increment is I mean not zero, is more than zero or less than zero. Both can happen. So normally, so this kind of scenarios we call accelerated motions. Okay, so either straight or curved path. Okay, so first we have to check whether our forces are balanced, and then after we have to check whether our moments are balanced. Why we should do the moment balance? Because the body, if the body is in equilibrium, it should not rotate. It should not rotate. Okay, it should not rotating with their axis or with some outside axis. So these are the two equations. The sigma f equals 0 and sigma m equals 0. Okay, then the f we can either we can further divide into three parts depending on our axes, fx, fy, fz. Okay, fx should be 0, fy should be 0, and fz should be 0. And also mx should be 0, my should be 0, and mz should be 0. And actually this is for the 3D case. That means so we that means it's a kind of a real object. But in our case, most of the time we use fx only. Sometimes fy, fx and fy both, but definitely not fy. Okay, very rarely it comes. And once you have that fz case, but you can further simplify it. I mean, you should be able to further simplify it and solve it. Okay, so that's the way. Otherwise, it's very difficult to deal with such kind of cases. Normally, it doesn't happen. Okay, then a simplified version of I. That's what I discussed. In most cases, in engineering practice, the loading of the body represents a system of co-planar forces. Okay, so because I mean, so this is not a real case. Okay, the co-planar causes, no, it's not a real case. Obviously, in the real scenario, so we have to, we should know there are any kind of direction the force can be active. Okay, but I mean, for the learning process and for the easy understanding, then we use only the co-planar forces, and the forces are in a single plane. That means 1D case. Okay. So then XY plane is taken to find equilibrium. So normally we use XY plane. So you know there are three lines, no, X, Y, and Z. So I'll explain it next class. Okay. With some drawings, that then you might find, you might get good some clear view of the planes. Okay, so just now we just go through with this, then I think it's enough. Then then because of that we only use fx is 0, fy is 0, and the mx is 0. So this is the thing. Okay, then also, you know, uh, you know actually what I want to tell, once we have the 3D case, uh, actually this is some out of the case, this is for just for your knowledge. Once we want to solve the 3D problem, so it's really difficult to solve only with the equations. Then we want to use matrix. I think now you know the matrix, and I think now you know the some arithmetics of the matrix. Okay, so matrices are very important case, especially in the engineering problems. So normally, if we have a, I mean, very difficult, I mean, there are very number of really high number of forces in either every direction, then we have to use the matrices. Okay, and fine. So and also there are some softwares also developed to solve such kind of problems. Okay, especially in the structural engineering. Sometimes we have to take account with the natural forces also. So natural forces means sometimes wind force. Okay, normally we are not consider wind force in this module because we don't want actually. But let's see, once we are going to build a 30-story building or 50-story building, the building is, it's like a skyscraper, no? Then sometimes some buildings have more than 100 stories. Okay, then then what happened? It definitely affect with the wind force, because if we have some strong wind, then we should the building should be able to withstand uh, with the wind. Then we should have to take the wind also. Then the problems are very serious and very complicated. Then sometimes we can't. I mean, our brain can't process this kind of complicated mathematics. Then what we can do, we use mathematics, and we use especially matrices to find some such kind of problems. Okay, so matrices are very important. Very important. So then depend on that depend on that the matrix calculations. There are some simulations and some softwares also developed in the computer environment. Sometimes you may know MATLAB, ANSYS. These kind of softwares are very popular, popular commercial softwares uh, with the engineers. So normally they are using to simulate and to design such kind of things. So actually, this is the beginning of that journey. Okay, once you want to go that much deeper, so first of all, you should know the basics. So this is the basics. So this is the place we discuss these basics, the fundamental things. So you should be able to get fundamental idea of the thing. Then yeah, well, you can have some. Okay, then the internal loadings. Okay, there are few the internal loadings and um, then yeah, so this is the we call internal loading because once so we have a big object and the object uh, has some uh, forces, outside forces, like we discussed earlier. Then what happened internally, we should know. We have to investigate it. Then that is the actual part or actual target of ultimate target. This is the ultimate target. So what happened internally? So then some forces are developed and some moments also developed. Okay. Then okay, we have to cut the section now firstly. Then we have to find what are the forces are developed and what are the moments are introduced. Likewise that. Okay. Okay, typically internal loadings are like, okay, we can categorize internal loading with these four. So this is the normal internal loading way. Okay, out of these there are no any such cases. So first thing is normal force. Force can be introduced. Okay, so what we call normal force, the forces are perpendicular with the surface. Okay, but keep in mind, not only the perpendicular one, but also some lateral forces are also developed. But what we are going to do, we divide it into the normal force and also the shear force. Shear force is lies on the plane of the area, and it is developed when the external loads tend to cause the two segments of the body to to slide over one. Okay, so this kind of force we call shear force. You can see here the shear force always develop along the surface. Okay, but normal force is perpendicular to the surface. Always it's perpendicular. But here it's normal. Sorry, it's along. Okay, it lies on the surface. Then torsion moments or torque. Okay, sometimes torsion moments, the torque, so can be developed. Uh, this effect is developed when the external load tend to twist one segment of the body with respect to one another about an external perpendicular. Then the bending moment also. Okay, so we talk what is the torsion and the torque later. Okay, so torsion is a very common one. It can happen. Okay, torsion and also bending. Okay, so these things are quite complicated rather than this, but this also we should discuss later in detail. Okay, then yeah, today we are going to look what are the failures due to the internal loadings. Okay, Sometimes you may see some videos on YouTube, on television. Okay, sometimes suddenly buildings are collapsed. The buildings are very, I mean, uh, the uh, 1 second ago it may fully fine. Okay, no problem at all. But suddenly it collapsed. Okay, normally we call these kind of collapsed catastrophic failures. Catastrophic failures. Okay, so what can happen in this kind of scenarios? Okay, normally because of the internal loadings, internally damaged, and it propagate, and finally it uh, tend to fail. Okay, suddenly it failed. Okay, once it damage, once it propagate, develop in externally, then we can see. Okay, there are some ruptures, and we can see some type of uh, broken areas. Then we might guess, okay, now is the things are in danger way. uh, then we can guess something can happen. But sometimes those are done in internal case, so we don't know. We can't guess anything, but it suddenly happened. Okay? So these kind of things can happen. And also sometimes you may heard some bridges are fallen during the March past. Okay? Okay, because why what is the main cause of that? Because of the March past, there's a scenario called resonance. Okay, the resonance also affect with the internal case, internally different. Okay, the resonance is a cause of the vibration. Okay, all atoms has some vibration. So once it come to their natural frequency, it resonates. And resonance may cause failures. This kind of, this is you can see is a kind of a shaft. The shafts, they are rotating. No? The duty of the shaft is rotation. So once it rotating, it can the what we call the failures can happen, and it propagate internally develop. We can't see, and finally it suddenly collapsed. Okay. So these are the failures. And yeah, so there's a slide I add with you, the importance of determination of the internal loadings. So what is the importance of the determination? So you might see some when you are walk or when you are drive on the road, then you might see some these kind of these kind of boards you can see. Weight limit is 30 tons. Weight limit is 3 tons. Why they are say like that? Okay, especially in the bridge, they mentioned what is the maximum load you can carry through the bridge. Uh, why? Because at the designing procedure, okay, when the bridge was in a designing case, so they decide this is the maximum load. So depend on this maximum load, they design the bridge. Okay. So once we want to carry a load more than this maximum load that is mentioned, so then it may cause to collapse of the bridge or collapse of the road. Okay. So then knowing these things and calculating these things are very important. then we should know the there's exact number. This is the number of the maximum load. And also sometimes you may see the engines lifetime of the engine is 10 years, or like sometimes shafts it's about 300,000 rotations, no more than 300,000 rotations. It may we can say it's about 10 years. The helicopter sometimes no engine is 10 years, but sometimes we don't know why they say 10 years, because of that internal loadings. Sometimes when internal loadings can happen, it can be where only 10 years. After the 10 years, this kind of sudden accident can be occur. Okay, sometimes it can't, but it can, it has some possibility. Okay, then uh, uh, by uh, um, by calculating the internal loads, we can have a comprehensive idea of such object. Okay, so that is one of our goal. Okay, once we are going to design something, we should know everything of this object, everything, not only the material and the technology, but also the mechanisms. What is the lifetime? What is the carrying loads? Where it can run, where it can't run. Those are very important cases. Okay, I want to give few exercise for you. Yeah. So, can you write down it? Yeah. Okay. Write down it, and it mentioned uh, the bar weight is W1. Okay. W1 is the bar weight. This is the weight of the engine, W, the capital W, and this W1. Or you can use simple W. Both are not a big point, a big issue. And you can think the bar is this that we call uniform bar. Okay, once it's a uniform one, then the W1 is acting on in middle of the bar, in the middle case, exact middle. Okay, so please write down the equation, or please take the photograph, and I want to give this as an exercise. So once you come, when you come the next week we have a physical session. So when you come to the class, so please bring this is as assignment. Okay, so you can use A4 sheet, or half sheet, or and you can uh, do this exercise. Okay, so I want to know what is the basic idea of you. So please try to do with yourself. Okay, don't copy. So copying is a bad thing for you. So don't do that. Try to develop your original script. Uh, doesn't matter it gets wrong or right. I just want to what we call the. I just want to know about your knowledge. Okay, so bring the exercise with you when you come to next class, and definitely I'll mark you, but I'm not going to mark the final answer. I only mark your attempt. Okay, when you attempt it, then I give the full marks. Don't worry. Okay, so this one I take as a assignment. So tell others also. I think we have 20. That means yeah, like 20 people absent. So tell them also. Then ask them to do this exercise and come with the exercise. Okay. So I'm really concerned about the copies. Okay, so I don't want anybody copy. So try to do by yourself, and yeah. Okay, I hope you all got the equation, and yeah, and yeah, this is the thing. Okay. Yeah, this is the end of today's session. If you have anything to ask, this is your time. You can ask. Don't be hesitant. Huh? Don't wait to ask from the friend. You can ask from me. Whatever you have, you can ask. Okay. If you have any doubt of this exercise, so you can come and meet me and we can discuss it. Okay. If you have any missing points or any place you don't understand, then I can help you. But first you can try. So the next class we can solve it. I mean, we can do it together. Until that, you will try to solve it. Okay. Okay, then if you don't have anything, so I'm going to wind up this session. Yeah. Oh, I forgot to record this. Okay, anyway, it's not a case.